Welcome to Advanced Algebra 2 Summer Bootcamp Round 7, Quadratic Functions. I'm excited to show you this Transfrm app on the TI-84, so you'll need that calculator. We also need this lesson page that I made for you. No problem, it's fine. And this activity page that I did not make, Compliments of Texas Instruments. It's a good one. So let's get started and organized. The first thing we'll talk about is just some basics about quadratic functions, which, just so you know, is slightly different than a quadratic equation. An equation is just a relationship, whereas a function is a little bit more specific. So we'll only be talking about curves that open up and down today. So a quadratic function is simply a polynomial function of degree 2. So quadratic, you might be thinking, why quad? That means 4. Shouldn't it be 4? Well, okay. So it's based on the idea that we're squaring something. And when we square something, that's a 2 that we raise to a power. And when we say square, it's like we're finding the area of a square. So the area of a 4-sided figure, really. So that's where the quad comes in. The parent function, or the general function that relates to quadratic equations, is y equals x squared. We could also write f of x in function notation equals x squared. So that's it for just the basics there. Now on the TI-84, what I want to point out is that when we look at the graph of this equation, y equals x squared, or any transformation of it, it would be either upward or downward opening parabola. So it's this nice curve. Next thing, let's talk about transforming quadratics. So there are 3 main ways that we could transform quadratics. Well, there's really a 4th way, but it's included in the first way. First thing I want you to know is that the letters A, H, and K that we'll use in these equations are just numbers. So they could be decimals, they could be fractions, they could be positive or negative, but they're real. So the first thing is a stretch or a shrink, and I mean horizontally or vertically. So that equation is y equals ax squared. So again, that a could be like 3 or 5, or it could be 1/3 or negative 1/5. A horizontal shift, the equation for that, we use a different letter, h, so we would say y equals x minus h squared. So we could still include that a in there, but if we're only focusing on the horizontal shift, we have x minus h squared. And it has to be in that form, x minus, and then h could be positive or negative. And then finally, the vertical shift, y equals x squared plus k. So that plus k is on the outside of the equation. And that k either shifts the graph up or down. And so we'll see what all of those numbers do in the equation in the Transfrm app. Do they make it go up, down, left, right? BA, BA, select, start. That was related to an old Nintendo game called Contra. Now, transforming quadratics on the TI-84. Just a quick note, you see the visual there, and we access this menu by pressing the Apps button, and then we arrow down. Now, since transform is the last option, you could arrow up from 1, and you'll get there quicker. Super fantastic. So if we combine all of those transformations from that previous section, we could get the vertex form. So the vertex form of a quadratic is f of x equals y equals, so you could use either one, a times x minus h squared plus k. So that combines all of the transformations into one. And when we work with that type of equation, we know quite a bit about the quadratic function we're working with. And we'll talk about that, what those things are. The vertex form on the TI-84, not much to say here except that you would use the Transfrm app, or you can use it, to see how A, H, and K affect the graph. So that's what we'll do with the app, and I don't know, I think it's pretty cool. I didn't really use that app much before, so that's why I'm excited to show you. The axis of symmetry, so this is fairly simple, and we could find out, this is one of the things that we could find out from the equation. The axis of symmetry is simply the line of symmetry. And so it's kind of like thinking about the axis in the center of the Earth that goes from the South Pole to the North Pole. It has symmetry on either side of that line, you know? So the line of symmetry for a parabola is what the axis of symmetry is. And it intersects the vertex. So it goes right through the vertex, just as the axis of Earth would go right through the core of the Earth, the center. Now, the equation of that line is x equals h. And this is all assuming we're dealing with quadratic functions, which are vertical or horizontal. So later on in like a advanced algebra 2 or pre-calc course, we could study conics, and a parabola is a conic section, and you could have sideways parabolas. So the axis of symmetry would be a horizontal line. Then take a look at the right there. You could see where the axis of symmetry is on that graph. If we just follow, if we start from the origin and we move to where the vertex is horizontally, 1, 2, 3, and then we go down a few units, we'd get to the vertex. So all we need to do is just draw a vertical line through the vertex, and then we'll have that line or axis of symmetry. So that's what's cool, is you could kind of see it fairly easily. The last thing is standard form. So that equation is, the equation is found basically by taking the vertex form and expanding out that x minus h squared. So just multiplying x minus h times x minus h. So that's an few algebraic steps that you can do. But the form is simply ax squared plus bx plus c. And that a in each one of the equations is the same. So if the a was 2 in the vertex form, then the a would be 2 in the standard form. But the b and the c are different. And I'm about to tell you what the b is, or how you write h in terms of b. Also, a, b, and c are just numbers. So positive or negative whole numbers, or negative numbers, whole, negative, integer, fraction, decimal. Standard form on the TI-84. All I want to say here is that you could find the vertex using the max-min feature. So that max-min feature is found by pressing second trace, which is the calculate feature, and you could find the max or min. So notice that the little graph on your page, you could see that there's a minimum to that parabola. So that also could be found by just working with b and a. So the shortcut is h equals the opposite of b, so negative b, over 2a. So notice from that standard form, if we take negative b and divide by 2a, that gives us the h value in the vertex. So what we could do then is plug in that vertex, that h value, and we could find out what k is. So that's pretty cool. So we could find out what the actual function value is. Okay, great. So the next thing that we'll do is work through the activity on the TI-84 calculator, and we're just working problem 1. I'll leave problem 2 for you to try it on your own, but really that vertex form is the one we want to focus on more anyways, because we could see more stuff going on. Okay, so that's all I have for you right now. Graphing quadratic functions, problem 1, the parabola. I have 2 lists of data here that I entered using my stat edit feature after I reset my calculator. I cleared everything. So remember, second plus 712 will do that for you. And I want to look at the first question with you. How are the x and y values related? What pattern do you see? So let's just look at these here, -2 and 4. How do we get from -2 to 4? Well, we could either add 6 or multiply -2 times -2. Two basic operations. How do we get from -1 to 1? Well, again, we could multiply by -1 or we could add 2. So notice in both of those things, that multiplication process, we multiplied by its own number. So 0 times 0 is 0, 1/2 times 1/2 is 1/4. And so what L2 is simply list 1 squared. So sometimes when we don't know the pattern, we have to start thinking in a different way, and this is the squaring way. And this is kind of nifty. L1 will show you the whole set, the whole list, and same with L2 up here. Okay, now what I'd like you to do is enter this data into your calculator using stat edit. So remember, stat, and then enter on edit, and you'll be able to enter these numbers. Now I want to show you one thing before you pause the video. How do you enter this fraction instead of a decimal? Not hugely important here, but I'll show you really quickly. The way that we pull up the fraction operator is we press alpha, y equals, and numerator, denominator. I never use these other options down here. Number 1, press enter. And then you see this fraction that's set up for you. This is part of the new OS. So we could do, like, let's say I want to do 3/4, 3, and I arrow right to 4. And then I press enter. And then you see that show up as a fraction. And then if I want to delete it, I simply go up to it and press delete. Okay, pause now and enter that data, and then when we get back, we'll check out some more stuff. Okay, so you should have all this data entered now, and some of the instructions show that press the right arrow so your cursor is on L2 and type L1 squared. So now I'll show you that instead of just typing all this stuff, what we could do is do L1 squared. So if you already entered that, that's great, that's fine. But what we could do here is press second L1, and then we'll square that. And what it will do, you won't see the data change, but it's actually the same because it was just entered by you or me. Okay, now I'm in the middle of this paragraph where it says, now that the data is entered, press second y equals for stat plot. So second y equals, and we want to turn the plot 1 on. So we press enter on that and we turn it on. Okay, now remember these 3 plots here. If we go to y equals, we'll see those 3 plots as well. So that's another way we could turn it on if we were in y equals. And to see this data, the directions say use zoom decimal. So this is the first time we'll use that. So zoom and then go down to decimal, which is 4. So you could have pressed 4. And now we see our data. Hey, that's pretty cool. And remember in the stat plot options, you could change the color and the symbols and all that stuff. The next thing that we'll do is enter the parent function. And a parent function is just like the main function that gives us the shape that we want. So y equals x squared, x and then squared. And sometimes we see this as f of x squared in algebra. And then we press graph. So we don't want to press zoom 6 there because it will reset our window. But then notice how that graph, that equation that we just entered, fits all that data wonderfully. Now, just to show you the contrast, I might change this color here. Instead of blue, I'll pick a different color. Let's go with green. Oops, I didn't change it. Oh my gosh. So down, enter, graph. Okay, so that green curve models the data. Question 2, describe the shape of the graph of the function. Well, this is fairly simple. It just kind of looks like a U, when we draw a U. But the official shape is called a parabola. So I would put U shape or parabola. Now, on to the meat to this activity. We'll explore how the value of a affects the graph of the parabola y equals ax squared. So let's check out this app. This is one of the first times I've ever used this. Ooh, okay. Oops, so I guess it's quicker to go up. Ha ha ha, that's what I thought. So transform, and notice there's no shortcut to the left of there, so you just have to arrow up or down. Press enter, and we'll press any key. So I'd like to press enter. Now, checking out y equals, and alpha a to enter a. So we already have this equation in here. So if we just typed alpha a, it will replace this x. So let's press second insert, and then alpha a. So now we have this equation ax squared. And notice how this looks just like your regular graphing calculator, but it says Transfrm Graphing App up here. And this is how you quit the app over here. So we're pressing graph now, and it pretty much looks the same. But you notice this thing down here, we have a equals 1. So I could press the right and left arrows to change the a value. And that's actually what it's asking us to do, explore different values. So if I make this a value really, really big, wait, that's weird. It shrinks the graph horizontally. It makes it skinnier. So this is like taking the top of the graph and like pulling it up to make it skinnier. And then if we make the a values small, oh, I guess we can't do 0.5, but if it was 0.5, it would be in between this and this. Okay. Okay, now part A in 3 is saying what's the value of a that makes the equation the parent function? In other words, what's the value of a that makes it the same as what it was originally? Well, it's 1. And then what happens to the graph when a is greater than 1? The graph gets skinny. And in parentheses, I say stretched vertically, like we're pulling the graph up. So if we were to stretch your body, if someone would pull your arms and your legs and keep going, oh my gosh, you would get skinnier. Part C, what happens to the graph when a is a negative number? Okay, so let's change the a to negative. Aha! It goes below the x-axis. So I would call this a flip or a reflection. So it's reflecting over the x-axis. And what happens when a is equal to 0? It becomes a straight line, a horizontal line. And the equation for this line is y equals 0. The last one here, part E. So what if we do something like 1/4 or 1/2? Okay, so let's try to do that. 0.5. And then 0.25. So all I did was started typing because a is the only thing that you can change on the screen. 0.125. So the smaller a is in terms of a fraction, the wider the graph gets. Kind of cool. So stuff that you could do, like if you were to do this by hand, it would take forever. You'd keep sketching curves and plotting points and stuff like that, and it would be pretty challenging. The next thing that we're going to do is adjust some other values. So the first thing that we did was adjusted the a value of the quadratic function. Now we'll adjust the b value. So what we'll do here is see if you could go right on x, press second insert, and you could always just retype all this. And then right here we'll enter b. So alpha b. And this is like the h in our notes, but Texas Instruments is calling it b. No big deal. Okay, now let's press window. And then notice it says press the up arrow to display the settings screen. So I'm at this X-min, so I'm going up, and it actually just kind of bounced to the settings screen. Okay, and So this is defining the start values and the step size. So use a equals 1, it says. So typing 1. And b equals 0. So we're seeing that b isn't anything first, then we'll change it, and then step equals 1. So we hit graph now. We have a similar screen, but we have a different equation, and then we have both a and b values now. Okay, now if we press up, you could press down too. You'll bounce between a and b. So that's called a toggle. And then we could press left or right to change the b values. Okay, so you could play around with that for a moment. I'm just pressing to the right, pressing to the left. So the graph is kind of doing exactly what I think it should do. Pressing right is making the graph go right, but notice that the equation says x minus b. So the equation has to be in this form for it to do what we expect. So part A, it says, what happens when b is positive? Doot, 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 doot. Well, it shifts to the right. How about when b is negative? The graph shifts to the left. Then it says part B, describe the changes in the graph as b increases. So if b increases, it's moving right. So similar to part A, but slightly different. You notice the nuance. When b is positive, it's to the right of the original graph, the parent function. But when b increases, it's moving to the right. When b decreases, it's moving to the left. Okay, neat. So that relates to the second thing we talked about in the lesson notes, which is just the horizontal translation or horizontal shift. The step 5 now will include the last part of the equation, which is the c value. So let's go back to y equals, and let's press second right arrow, takes us to the end of the line, plus, and then alpha c. So now this is our vertex form of a quadratic function or quadratic equation. And a quadratic function is one that passes a vertical line test that there's only one y value for each x. So with quadratic functions, we always have a graph that's vertical, so either upward or downward. But if it's just a quadratic equation, it doesn't have to be a function. We could have a sideways one as well, left or right. So we're pressing window, and we're going up to settings, and then we'll change these values appropriately. So a equals 1, b equals 0, and let's do c equals 0 for now. It doesn't say what settings. So then we'll press graph, and then again we could toggle between the a, b, and c. So let's go to c, and let's press the right arrow and see what happens. Hey, all right, that's kind of something that we may have expected, that if we go to the right, it's associating with a positive thing, and going to the left, it's associating with a negative thing, which is a vertical shift. So when c is positive, when c is positive, then the transformed graph is higher than the parent graph, the parent function. And when c is negative, it's lower than the parent function. So what happens as you press the right arrow to increase the value of c? The curve shifts up. And then notice that equation, it says plus c. So if you have a positive c value, it's a shift up. But if you have this minus sign with a b value, as long as that b is a positive b with a negative in front of it, it's kind of weird, but you'll learn more about it later. Number 6, change b and c so that the vertex of the parabola is at 4, -3. Okay, we could do this one together. You could always pause me and try it first. So I want to go to 4, -3, and so let's see, the b value, 1, 2, 3, 4. Oops. So there's 4. And then I'll go to C. I have to go left to go down. So 4, negative 3. And then really, my A value could be anything. It doesn't really matter as long as the vertex goes through that point. So the equation for this, we would just plug in all these points into this general form. So then we have 1 outside, or don't write a number at all, x minus 4 quantity squared minus 3. Notice it says plus whatever c is. So plus a negative 3, which is just minus 3. Great. So the second part of B, just a little bit of a conversation we'll have here. The formula of a parabola can be written as a times x minus h squared plus k. So why is this called the vertex form? So we touched on that in the lesson. We just saw it in action here with A, B, and C. And now we're simply talking again about what does A do? A is telling us something about the curvature, which is really the most challenging thing to kind of process and graph on your own. H, or B, is helping us find the x value of the vertex. So notice that B there, that's the x value of the vertex. And then K, or C, is telling us the y value of the vertex. So when we're working with quadratic functions, parabolas, it's really helpful to be in vertex form, to have an equation that's in vertex form, because you can sketch the graph really quickly and know a good amount about the graph really quickly as well. And in case you didn't know, this applies to, we use quadratics and parabolas to model things that are flying on Earth, that are being tossed up and coming back down because of gravity. Okay, the next thing that we're doing is exiting the app. So we'll go to y equals, and then we could arrow up and then to the right. And then press enter. Quit that bad boy, and we're back to a main screen. Great. Okay, so number 7, the next thing is describing 1/4 times x minus 0 squared minus 3. And thinking about what's happening, what's the vertex, and then graphing that. So go ahead and pause the video right now, and I'll show you what the answer will be in a moment. Okay, now I'll just replace these values here. So I'll do alpha y equals and enter 1/4 right here and delete the a. I'll make the b 0 and then I'll subtract 3. Now don't do minus 3 or negative 3. It has to be a subtract 3. Okay, and then let's turn this, should we turn the stat plot off? I don't know, let's just graph this. So this opens up because the 1/4 is positive, and then the vertex is at 0, 1, 2, 3, 0, negative 3, because of the 0 in the equation and the negative 3 at the end of the equation. Fantastic. So the last thing, I'll just start with you, and then that will be it for this part, for this problem 1. So let's turn the stat plot off. Enter. And then it says, draw a line parallel to the x-axis that intersects the parabola in question 7 twice. So what does that mean? Draw a line. Well, it means come up with an equation of a line that will intersect the parabola twice. So I'll do one with you, and then you could do the other 2. Pardon me. So looking at this graph, I see that I can put a line at negative 1 or negative 2. I could also do one at 0 or one at 1. So I want to start with -2. So let's go to y equals, yikes, and then negative this time 2. If there was an operation like between two numbers or variables, we would put minus. So -2. And notice that this line intersects the parabola twice. And so this leads up to something that we study in Advanced Algebra 2 and Pre-Calc that helps us understand parabolas even deeper. So I'm filling out this table here, and the line I chose is y equals -2. Now let's find the left intersection. We can maybe guess that it's at -2. Let's just be sure. Second calc, intersect. First curve, second curve, enter. And then I want to get close to this one. Aha, -2, -2. So the left intersection is -2, -2. How far is that from the y-axis? Well, 1, 2 units. And then I don't have to do the right intersection on the graph. I know that it's going to be 2, -2. So I could go over there and show you. It's basically right here, 2, -2. I didn't confirm that with using my arrows. I have to use the intersect feature. But I know it has some symmetry. And that's one of the things that this leads you to see, is that there's symmetry in the graph. And then how far is this point from the y-axis? 2. So you should do that for 2 more lines, just so that you could see that they're not always integers or whole numbers. Well, thanks for following along with me through that app. I hope you found it kind of nifty and hope it's useful in the future. The next thing you should do is check out these 4 exercises on this page. Work through those, and I'll have the solutions in the description for you. And then keep going through problem 2. If I went through problem 2, this would be a really long video, but I think you could do that on your own and it would be worth it. Oh, I do have one more thing though. I just wanted to record this experience. You know, we've been together for all these videos, and I don't want to miss the chance to just make a memory. So just stay still. Got my spy camera here. I hope you don't have anything incriminating in your room or house. Okay, got it. Thanks. Have a good one. Thanks for watching. See you in the next video.